Dear students, welcome to the channel of Seekers. In this session, we will study chemical equation, terms related to the chemical equation, and hit and trial method to balance a chemical equation. Let's begin. So first things first, what do we mean by the term chemical equation? In order to understand the concept of chemical equation, let's take the example of very common chemical reaction between quicklime and water. As you can see in the video that water and quicklime react to form a new compound called slacked lime or calcium hydroxide with the evolution of heat energy. Now what if we want to study what happens during the course of this reaction? Here comes the need of framing a chemical equation which could clearly represent actual events taking place during the course of the chemical reaction. That is, it helps us to study what happens at the level of atoms and molecules during a chemical reaction. So, by definition, a chemical equation is used to express an actual chemical reaction in terms of symbols and chemical formulae of various substances involved in the reaction. As I have already stated, the example of reaction between quicklime and water to form slacked lime with the evolution of heat energy. Let us try to write chemical equation for the reaction between calcium oxide and water. The very first step in writing the chemical equation for a reaction is that we should know beforehand the symbols of elements and chemical formulae of the compounds involved in the reaction. So let's write the chemical equation. So quicklime, the chemical name and chemical formula of the quicklime is CaO, that is calcium oxide, which is in the solid state, and water H2O both reacts to form calcium hydroxide, which is a white colored suspension in the water. So the chemical formula of calcium hydroxide is CaOH twice, which is commonly called slacked lime. So in this reaction, heat energy is also evolved. Here, I also want to add chemical equations not only give information about the identity of participating substances, rather it also tells us about the physical state of the reactants and products and energy changes accompanied during the chemical reaction. Now let us see other terms related to the chemical equation. The substances present on the left-hand side of the equation are called reactants, whereas those present on the right-hand side of the equation are called products. For example, in this reaction, calcium oxide and water act as reactants which combine to form the product calcium hydroxide. So the another example is the reaction between magnesium ribbon and oxygen from the air. Magnesium ribbon reacts with oxygen from air to form a white colored powdery substance called magnesium oxide. Let us try to write chemical equation for this reaction. Magnesium plus oxygen, forward arrow, magnesium oxide. If we carefully see this equation, we will notice that the number of atoms is not equal on both sides of the equation. Such an equation is called a skeleton equation. Hence, our next task is knowing how to balance an unbalanced skeleton equation. Let us reconsider the equation of the reaction between magnesium and oxygen. In this equation, on the reactant side, there is one magnesium atom and two oxygen atoms. On the product side, we have one atom each of magnesium and oxygen. So, in order to balance this skeleton equation, the first step will be to convert the oxygen molecule into atomic form. When we do so, both the sides of the equation would have equal number of atoms. Step 2 will be we will multiply the whole equation with 2. When we do so, we will notice that we have coefficients in front of magnesium, oxygen and magnesium oxide. These coefficients of balanced equation are called stoichiometric coefficients. So far as balancing of this equation is concerned, we are almost done. Now all you have to do is convert the two oxygen atoms into the molecular oxygen. And that's it. We have our final balanced chemical equation for the reaction. Let's take another example of reaction between magnetite and hydrogen gas. Magnetite reacts with hydrogen gas to form iron element and water. Let's start writing skeleton equation for this reaction. The formula of magnetite is Fe3O4, which is in the solid state. Then hydrogen gas H2 in the gaseous form gives rise to iron element, which is in the solid form, and water in the gaseous form. This is the desired skeleton equation of the reaction. Now we will learn how to balance this equation. If you notice carefully, on the left hand side of the equation, there is hydrogen gas which is in the elemental form. Here we will convert the molecular form of hydrogen gas, that is H2, into the atomic hydrogen, as you are looking in the video. On the left hand side, there are 3 iron atoms in the magnetite, and so we will write 3 in front of iron on the product side. Similarly, there are 4 oxygen atoms in the magnetite. So on the right hand side, we will place 4 as a stoichiometric coefficient in front of water molecule in order to make the number of oxygen atoms 4. Our last step would be to count the number of hydrogen atoms on the right hand side, that is on the product side. Now there are 8 hydrogen atoms on the product side. So in order to balance the number of hydrogen atoms, we will put 8 as stoichiometric coefficient on the left hand side in front of a hydrogen atom. The last but not the least step would be to convert the atomic form of hydrogen into the molecular form. So if we convert atomic hydrogen into the molecular form, we get 4 molecules of hydrogen gas, and this is a desired balanced chemical equation. Dear students, the key to success is constant learning and extensive practicing. So practice makes a man perfect. If you want to get firm hold on this topic of chemical equations, you need to practice and practice extensively. So let us take one more example of reaction between benzene and oxygen. Benzene reacts with oxygen to form carbon dioxide and water. So let us write the skeleton equation of this reaction. So benzene, its formula is C6H6, which is in the liquid form, reacts with oxygen, that is O2, which is in the gaseous form, to form carbon dioxide gas, that is CO2, and water, that is H2O. This is the skeleton equation. Now let's balance this skeleton equation. So the very first step will be conversion of elemental oxygen on the left hand side into atomic form. In the chemical formula of benzene, that is C6H6, there are 6 carbon atoms. So on this track, we will put 6 on the left hand side in front of carbon dioxide molecule as a stoichiometric coefficient. Then there are 6 hydrogen atoms on the left hand side in the benzene molecule. So to make number of hydrogen atoms 6 on the right hand side, we will write 3 in front of water molecules. Now the next step will be to count the number of oxygen atoms on the product side, and we will put the same number of oxygen atoms on the left hand side, that is on the reactant side. So if we count the number of oxygen atoms on the right hand side, we get 15. oxygen atoms. So we will put 15 on the left hand side in front of oxygen atom. Now as 15 is not an even number, it's an odd number, so we cannot convert the odd number of oxygen atoms into the oxygen molecule. So it's not possible. So in order to resolve this problem, we will multiply the whole equation with number 2. And when we multiply the whole equation with 2, we will get 2 molecules of benzene, 30 atoms of oxygen and 6 molecules of water. Now we are almost done. Lastly, to get our final balanced equation, we will convert atomic oxygen into the molecular oxygen with the same number of oxygen atoms. That is, finally we will get 15 oxygen molecules. So this is our final desired balanced chemical equation. Dear students, for practice, I have given a few more skeleton equations. The first equation is sodium carbonate reacts with hydrochloric acid to form sodium chloride, carbon dioxide and water. And the second equation is aluminium reacts with oxygen to form aluminium oxide. And third equation is iron reacts with sulfuric acid to form ferric sulfate and hydrogen gas. And the last equation is calcium carbonate reacts with hydrochloric acid to form calcium chloride, water and carbon dioxide. For chemistry notes of other chapters, you can visit my Facebook page and my website theseekers.online. Keep on learning, keep on smiling, have a nice day.